Okay folks, buckle up. Tonight on the Mysteria Archive, we're diving headfirst into the quantum rabbit hole. Reality's about to get weird, like your toaster might be conscious weird. So, get comfy, keep an open mind, and let's see just how deep this glitch in the universe really goes. Get ready for a wild ride. You reach for your keys, and they're gone. You check the counter, the table, even the floor. Nothing. Then, a few minutes later, they're right there, exactly where you already looked. You tell yourself you're tired, distracted, but what if it wasn't you that slipped up? What if it was reality? Our world seems solid, predictable, grounded by laws of physics that never fail, until you look closer. Because the deeper scientists peer into the fabric of existence, the stranger it becomes. Particles that blink in and out of being. Objects that act differently depending on whether someone's watching. A universe that might not be made of matter at all, but of information. It's as if the cosmos runs on invisible code, one that can rewrite itself, refresh itself, even glitch. And every so often, maybe we catch it in the act. A déjà vu, a coincidence too perfect to be random. A brief moment where something in the system stutters. Tonight, we're diving into the world of quantum mechanics, where the rules of reality bend, time folds, and observation itself might be the ultimate creator. Because if reality can glitch, what does that say about us, the ones inside it? Okay, let's be honest. We've all had those moments where we swear reality's trolling us. You know, where your phone disappears for 5 minutes and then it's just back. It's like the universe hit Control Z. But that's exactly why quantum mechanics feels so unsettling, because it suggests the universe might actually work that way. Now, things don't exist in one state until they're observed. Particles teleport information across space, and reality itself seems to flicker between possibilities. Now, don't worry, we're not about to say your missing socks are in another timeline. Well, maybe, but quantum mechanics forces us to ask, how stable is the world really? And is it possible that the weirdness we see on a subatomic scale sometimes leaks into our everyday lives? The quantum revolution. Reality isn't solid. It's hard to overstate how much quantum mechanics changed everything we thought we knew about reality. Before it, physics was simple. Matter was solid, predictable, and followed clear rules. You drop an apple, it falls. You flick a light switch. Photons travel in straight lines. Easy. But when scientists began studying the tiniest building blocks of nature, particles smaller than atoms, everything broke down. The most famous example? The double-slit experiment. Fire particles of light, photons, at 2 slits. If they're just particles, they should form 2 bands on the wall behind, but they don't. They form interference patterns, waves overlapping, as if each photon passed through both slits at once. It behaves like a wave until someone observes it. The moment you watch, it stops behaving like a wave and acts like a solid particle instead. Now that single observation changes reality. Not the equipment, not the experiment, just the act of looking. And that's the heart of quantum mechanics. At the smallest scales, the universe isn't solid. It's fuzzy, probabilistic, a haze of potential that doesn't decide what it is until it's observed. Which leads to an uncomfortable question. If reality only becomes real when it's measured, who or what's doing the measuring when no one's looking? Physicists like Niels Bohr and Werner Heisenberg argued that consciousness, the observer, plays a fundamental role in shaping the outcome. Einstein hated that idea, famously saying, "I like to think the moon is there even if I'm not looking at it." But quantum mechanics, frustratingly, doesn't seem to care what Einstein likes. The math says observation changes reality, and we're still trying to figure out how. You have to feel a little sorry for the scientists who first discovered this stuff. Imagine spending your whole life believing the universe is a giant clock, then realizing the gears are made of mist. The double-slit experiment is like the ultimate cosmic prank. Reality behaves one way when no one's watching, then instantly flips the moment you peek. It's like the universe saying, you weren't supposed to see that. Now, that doesn't mean your thoughts can make objects appear out of thin air. This isn't Hogwarts. But it does suggest that observation, and maybe even consciousness, plays a bigger role in shaping the world than we once believed. So, if reality needs us to exist, what exactly are we looking at? Entanglement, the hidden web. If quantum mechanics has a party trick, it's this, entanglement. The idea that 2 particles can become so deeply connected that what happens to one instantly affects the other, no matter how far apart they are. Split a pair of entangled photons, send one to New York and the other to Tokyo, change the spin of one and the other flips instantly. No signal, no delay, not even the courtesy of obeying the speed of light. Einstein hated it. He called it spooky action at a distance, because it seemed to defy everything relativity stood for. Yet, experiment after experiment has proven it's real. The connection is instant, as if the two particles aren't really separate at all, just two sides of one invisible coin that happens to straddle the universe. Some physicists describe entanglement as a hidden web that binds the entire cosmos together. Not through space, but beneath it, a realm where distance doesn't matter because everything is already connected. Now, here's where it gets weird. Some fringe theorists, and even a few bold scientists, have wondered if entanglement doesn't stop at particles. Could it scale up? Could it connect systems or minds? There's speculation that the human brain's neurons might exhibit entanglement behavior, tiny quantum effects syncing our thoughts in ways science hasn't fully mapped. Others suggest entanglement might be the physical mechanism behind intuition, déjà vu, or even synchronicity, the sense that the universe sometimes winks back at you. That might sound like sci-fi, and it is, but the physics doesn't rule it out. Because entanglement isn't just a theory, it's the backbone of quantum computing, quantum encryption, and the next generation of technology. And if the universe really does run on this hidden web of instantaneous connections, maybe that explains why sometimes it feels like everything and everyone is already linked. Quantum entanglement is one of those things that sounds like it belongs in a Marvel movie. I mean, two particles billions of miles apart, somehow talking faster than light. That's some next-level cosmic texting. Now, Einstein thought it was impossible, but experiments keep proving him wrong, which must really annoy him wherever he is. And sure, it's easy to laugh at the idea that humans could be entangled. But let's be real, we've all had those moments where we think of someone and they text 2 seconds later. Maybe coincidence, maybe physics having fun at our expense. Either way, entanglement reminds us that separation might be an illusion. The universe could be less of a machine and more of a mind. The universe as code, it from bit. In the 1980s, physicist John Archibald Wheeler, a mentor to Richard Feynman, proposed something radical. It from bit. His idea was that everything, every atom, every galaxy, every moment emerges from information, not matter, not energy, but data. Imagine the universe not as a physical place, but as a vast information system, reality as code. Wheeler argued that at the quantum level, particles don't exist until information about them is recorded. In other words, to be is to be measured or processed. Sound familiar? It should, because it's eerily close to the simulation hypothesis, proposed decades later by philosopher Nick Bostrom. If reality is information, then maybe we're living inside a cosmic program, a simulation so vast and complex that we mistake it for a universe. Even mainstream physics echoes this. The holographic principle, developed from black hole research, suggests all the information that defines our 3D universe might actually be encoded on a 2D surface at its edges. Like a cosmic hard drive projecting our existence inward. Every equation, every field, every photon might just be bits of data rendered into experience. And if that's true, then glitches aren't so far-fetched. Those strange coincidences, time slips, déjà vu moments, maybe they're the cosmic equivalent of a buffering error. A quick reality refresh while the code realigns. The idea might sound wild, but cutting-edge physics increasingly treats information as the most fundamental ingredient in the cosmos. Matter decays, energy shifts, but data, information, remains. So, if it from bit is true, then maybe what we call reality isn't a stage set in stone, but a simulation of observation itself, endlessly updating. Okay, so if reality really is made of information, that makes us what? NPCs with better hair? But seriously, Wheeler's it from bit theory sounds like the universe is one giant cosmic computer, and we're inside the code trying to debug ourselves. It's equal parts mind-blowing and existential crisis. Now, does that mean we're literally living in a simulation? Well, not necessarily, but it does suggest that information, not stuff, is the universe's true currency. Everything that happens might just be data being processed by something. And if that's the case, those little moments where the world feels off, maybe they're not just in your head, maybe the code glitched. Either way, I'm definitely saving my progress before we go any further. The role of consciousness, the quantum mind. Here's where quantum physics starts getting really personal, literally. Because what if consciousness itself isn't just a side effect of the brain, but a quantum process? In the 1990s, physicist Roger Penrose and anesthesiologist Stuart Hameroff introduced a theory called orchestrated object reduction, or ORCH. Their idea was bold, that the brain's neurons contain microscopic structures called microtubules, and within them, quantum processes could occur. In other words, your thoughts might be built on quantum mechanics. If that's true, it could mean consciousness isn't confined to biology. It's a quantum field, one that interacts with reality on a fundamental level. Now, here's where things start to sound like philosophy wearing a lab coat. The observer effect in quantum physics says that the act of observing a system changes it. So, if consciousness collapses quantum possibilities into a single reality, then awareness itself might be the glue that holds the universe together. Could collective consciousness, all of our perceptions combined, be what stabilizes this shared version of reality? And when that collective focus falters, do we see the seams? Maybe that's when things start to glitch. Mainstream scientists are skeptical, of course. There's still no solid evidence that the brain operates in a quantum state. It's messy, warm, and full of noise, conditions that typically destroy quantum coherence. But research into quantum biology, like how birds navigate using quantum effects in their eyes, shows nature can do strange things even at the microscopic level. So, maybe, just maybe, consciousness isn't a spectator sport. Maybe we're all active participants in creating the universe we experience, one thought, one observation at a time. Okay, so this is where things start sounding like your brain has Wi-Fi. The idea that our thoughts could be quantum events is wild, but also kind of poetic, right? Penrose and Hameroff basically suggested that awareness isn't just neurons firing, it's quantum information, meaning consciousness could exist everywhere. Like, imagine realizing the universe might literally be self-aware. Now, most physicists roll their eyes at that. They prefer their quantum mechanics without the spiritual garnish, but even skeptics admit the line between physics and consciousness isn't as clear as we'd like. So, if reality really forms through observation, maybe consciousness isn't inside the universe at all. Maybe the universe is inside consciousness. Quantum time. The future leaks back. Time, we're told, moves in one direction. Past to present to future. Simple, right? Well, not in quantum mechanics. In the quantum world, the arrow of time starts to bend. One of the strangest ideas to emerge is retrocausality, the possibility that events in the future can influence what happens in the past. Yeah, it's as weird as it sounds. Physicist John Wheeler proposed the delayed choice experiment, a twist on the classic double-slit setup. In it, the decision to measure a particle is made after it's already passed through the slits. Yet, somehow, that choice seems to determine what the particle did before it was measured. In short, future actions can shape past events. Later, physicist John Cramer expanded on this with the transactional interpretation, which describes reality as a handshake across time. Waves of probability traveling forward and backward, meeting in the present to create what we call now. It's mind-bending stuff, but experiments have backed up the math. At the quantum level, time doesn't seem to care about our rules. And that's where the fringe thinkers step in. If time isn't linear, if the future can bleed into the past, then what we perceive as glitches could be little moments of temporal interference, a déjà vu, a correction, a cosmic refresh. Some even suggest consciousness might exist across time, constantly editing the movie reel of reality, tweaking, revising, stitching moments together. It's speculation, sure, but it reminds us that time might not be a straight line, but a loop, one we're both watching and writing at the same time. So yeah, apparently time can go both ways now. Great, as if Mondays weren't confusing enough. Retrocausality basically means the universe might be editing itself on the fly, future events reshaping the past, like a cosmic undo button. It's like the timeline of software patches. Now, before you go blaming quantum physics for your bad life decisions, this doesn't mean you can time travel your way out of awkward moments. But it does suggest that what we call cause and effect might be more of a conversation than a command. And maybe when we sense those weird blips, the déjà vu, the tiny inconsistencies, we're not crazy, we're just catching the universe mid-edit. The quantum vacuum, the invisible machinery. If you could somehow take everything out of the universe, every atom, every photon, every speck of dust, you might expect what's left to be nothing. But that's not how quantum physics works, because even in nothingness, something stirs. What we call empty space isn't empty at all. It's a restless ocean known as the quantum vacuum, a field where tiny particles constantly flicker in and out of existence. They appear, interact, and vanish again in a trillionth of a second. Physicists call them virtual particles. They're invisible, unmeasurable directly, yet their effects are undeniable. They literally tug on the universe. The Casimir effect, discovered in 1948, proved it. Two metal plates placed extremely close together attract each other, not because of magnetism or static electricity, but because of the energy of empty space itself pushing them together. The vacuum, it turns out, has pressure. Now, this unseen ocean could be the foundation of everything, what some physicists call the zero-point field. Others describe it as the fabric of the cosmos, the hidden energy matrix from which matter and light emerge. And here's where the science starts sounding almost mystical. Ancient traditions spoke of an all-pervading energy, the ether, chi, prana, a subtle field connecting everything. Modern physics, in its own way, seems to have rediscovered that idea, stripped of the poetry but echoing the same truth, that space itself is alive with potential. Fringe theorists suggest this could be the machinery behind the glitches, maybe what we call coincidences, synchronicities, or sudden flashes of insight are the ripples of this vast invisible sea, reality recalibrating itself. Because if the vacuum isn't empty, maybe the universe is thinking. So yeah, even nothing is busy doing something. The quantum vacuum is like the universe's background app, constantly running whether we notice it or not. The Casimir effect kind of proves it. Space literally pushes back, which is wild when you think about it, because that means the universe has a built-in hum, an endless vibration. Now, whether that's the same thing ancient mystics called life force energy is up for debate. But it's funny how old ideas and new science keep circling the same mystery. And if there's an invisible field connecting everything, maybe we're not separate from it all. Maybe we're just little waves on a much bigger sea. When physics meets the paranormal. This is where the story crosses the thin line between physics and philosophy, and maybe even the paranormal. Because for decades, people have tried to use quantum mechanics to explain the inexplicable. Telepathy, synchronicity, precognition. Not as fantasy, but as a side effect of a universe built on entanglement and uncertainty. Let's be clear, there's no proof that your brain can quantumly link with someone across the world, but the principles of non-locality, the things that can be connected instantaneously across space, give the imagination room to play. The physicist David Bohm, one of Einstein's protégés, believed the universe is far more interconnected than we realize. He proposed what he called the implicate order, a hidden layer of reality where everything is enfolded into everything else. What we see, space, time, matter, is just the unfolded surface of that deeper order. In Bohm's view, consciousness and the physical world aren't separate. They're reflections of one underlying whole, which could explain why meaningful coincidences or Young's synchronicities sometimes feel too perfect to be random. Of course, mainstream science keeps these ideas at arm's length, partly because they sound like metaphysics, and partly because they're nearly impossible to test. But still, the overlap between quantum physics and the mysteries of human experience is too intriguing to ignore. Maybe what we call the paranormal isn't supernatural at all. Maybe it's subnatural, buried deep in the quantum rules that build reality itself. Because if particles can talk across galaxies, maybe minds can too. Okay, so this is the part where science and mysticism shake hands. Then immediately pretend they didn't. Now, physicists get nervous when people use quantum theory to explain ghosts and telepathy, but honestly, can you blame them? Still, it's hard not to notice how quantum mechanics already sounds paranormal. Particles communicating instantly across space. Reality changing because you looked at it. That's ghost story material right there. And even if we never prove psychic powers or telepathy, quantum theory reminds us that the universe is way more connected and way stranger than we thought. Maybe the paranormal isn't breaking the rules of physics. Maybe it's what happens when physics breaks our rules. The universe watching itself. So, what if all of this, the uncertainty, the quantum weirdness, the glitches, the déjà vus, isn't a sign that something's broken, but that something's alive. Quantum physics doesn't just describe the universe, it reveals it as a participatory act. Every particle, every wave, every choice we make, they all seem to exist in a kind of cosmic conversation. When we observe, measure, or even think, reality responds. Maybe that's why so many of us feel that strange sense of connection, like the universe is both stage and audience. That we're not just living in reality, but with it. Because at its deepest level, quantum mechanics hints that the world isn't a fixed machine ticking away under the laws of physics. It's fluid, relational, aware in its own strange way. Maybe the glitches aren't mistakes. Maybe they're tiny signals from the code, whispers reminding us that this world is being rendered in real time, shaped by consciousness, curiosity, and observation itself. So when you notice the small oddities, the missing keys, the flicker of déjà vu, the impossible coincidences, don't brush them off. Maybe that's not the universe malfunctioning. Maybe that's it looking back. Because in the end, quantum mechanics might be telling us something ancient and profound, that reality isn't separate from us at all. It's us watching itself. I love this idea that reality isn't this cold, distant machine, but something participatory, like we're part of the engine that keeps the universe running. Whether it's consciousness collapsing wave functions or just physics doing its mysterious thing, who knows? But it's kind of comforting to think that we're woven into the fabric of it all, not just passengers on this cosmic ride, but co-authors of it. So yeah, maybe we don't live in a glitching universe after all. Maybe the universe just blinks to see if we're paying attention. Thank you for watching, and I hope you enjoyed this one. And if so, why not check this one out on the screen now? And don't forget to like, share and subscribe. It really helps the channel out and I'd really appreciate it. And let me know in the comments below of videos you would like to see next time. Okay, my friends, be safe, and until next time, stay curious.